All right, let's move on to 9.3. This question says, find the equation of the tangent to G. Which one is G? It is this graph. This is the equation of it. At point P, where is point P? This is point P. In the form y is equal to something. What is that? Sifuna tangent. In the tangent, it's nothing else but a straight line. So masifuna equation of a tangent, so sifuna ubani m no c. That becomes important. Equation of a tangent, y is equals to mx plus c. So sifuna m no c. Because ngithola equation of a tangent, fanele ngibe ne gradient ne point. Now, kuthiwa le tangent engiyifunayo, it cuts, ithinta la equation yami, ithinta at point P. Right. This is typical of my tangent. It touches this graph at point P. Now, ithini indaba? Ithi akusho ukuthi ngiyalazi point. I do have the point, which is point P. Because ngithola equation ngishoda ngani? Ngishoda nge-gradient. Now, but at this particular point, where x is minus 3 and y is 11, I know that the gradient of the tangent will be the same as the gradient of the cubic graphing of the cubic function at this particular point P. So the gradient of the tangent is the same as the gradient of the cubic graph at point P, where x is minus 3. In other words, if I can't find the gradient of the straight line, of the tangent, I can find the gradient of the cubic function at point P, because at that particular point, both graphs are the same. They are equal at the point of intersection. Is there a way that will help me to find the gradient of the straight line? In terms of the straight line itself, I can't. Hence, I've got to use the cubic graph, because I know that its gradient at this particular point will be the same. But how do I find the gradient of the cubic graph? When I differentiate, when I'm looking for the derivative of the cubic graph, I will be looking for the gradient. And that gradient will be the same as the gradient of the tangent at this particular point, because those 2 points are the same. Ithini indaba ye-gradient of the tangent. Remember in the previous question, we said we let the derivative, this is the gradient. So this point will be the average gradient. So that gradient will be the same as the gradient of the straight line at this particular point. So MAV, I'll just continue from here. MAV, average gradient, MAV will be equals to that, which is minus 6x squared minus 6x plus 12. This is the average gradient. In other words, asiyibize lento bayibiza ngoba le graph ngo-G of x prime. So this is our gradient, which is our gx prime. It is equals to that. It came from here, this times this, it's minus 6x, which is this one. This times this, it's minus 6x, which is this one. Differentiate to 12x, it becomes 12. Differentiate to 20, it becomes 0. That's where it came from. In there, the gradient. Already we do have a point, but short and high gradient. But that is the average gradient. The gradient anywhere on this graph. But we are specifically looking for the gradient where x is equals to minus 3. Who at x? Minus 3. So in other words, we're looking for where x is minus 3. So this will be equals to minus 6 into minus 3, minus 6 into minus 3, plus 12. This then becomes, let's check what this gives us. 6 times 3, 6 times 3, go positive, go kubili, it will give us 18. Nomunyu 18, or it's plus 18 again. Plus 12. Okay, let's look at this one again. This is G. Oh, I think there's a mistake here. This is 6x squared, so this must be squared. Let's do it again. So it's minus 3 squared, it will be 9. And 9 times minus 3, it will be minus, let's do it again, minus 9 times 6. This will give us minus 54 plus 18. 18, it gives us minus 36 plus 12. Plus 12, it gives us minus 24. So this one gives us minus 24. This is the gradient. We do have the gradient now. We do have m. Remember, we do have m. We're looking for the equation. Equation which find the equation of the tangent. Tangent is a straight line that touches any figure at one point. Now that we do have the gradient, let's short and y-intercept. But since we do have the gradient, m in this case, and we do have point P, we can find the equation using the formula y minus y1 is equals to m into x minus x1. Remember, we're required to write it in that form, in the form y is equals to something. X1 lo, y1 lo. This is our gradient, so we've got everything that we need. Let's do this thing. So this will be y minus, what is y1? In this case, our y1 is 11, is equals to, what is our gradient? In this case, our gradient is minus 24, minus 24. Remember, this is the gradient of the tangent, m tan. Gradient of the tangent is 24 into x minus, what is our x1? It is minus 3. So this will turn this to be positive 3. Y minus y1 is equal to m into x minus x1. Asambeni, let's break those brackets. What do we have now? Let's make it y is equal to something. It means that we need to take this one, who's an positive. It will be y is equals to, this times that, it's minus 24x, 24 times 3. 24 times 3 equals about 24 about 3. 24 times 3, it will give us 72. Okay. Yes, it is 72. This times this, it's 24x. This times this, it's minus 72. 72 plus 11. What do we have at the end? Y is equals to, this is minus 24x. 2 minus 1, it is 1. 7 minus 1, it is 6. So it's minus 61. This is the equation of a tangent. What is this saying to us? If this is 20, so another 20 will be somewhere here, it will cut it down there at minus 61. That is what we call the equation of the tangent. I want us to look at the last problem in this section here that I want us to understand as well. This one says, determine the value or values of k for which minus 2x squared minus 3x plus 12x plus 20, which is the same as this graph. So it is exactly that graph. It is exactly the graph of G. Will be equals to k, has 3 distinct roots. Let's read the question again. Determine the values of k for which this graph, which is this one in particular, equals to k, has 3 distinct roots. Let's look at the present state of this graph. Does it have 3 distinct roots? No. Khona le bese khona khona lawo 2. Kusho lama roots 8 awayimele ngokwawo mathathu. Ithi indaba kungaba ubani k. In other words, how can we move this graph such that it has 3 roots? Now, let's look at this scenario. Suppose makuthiwa ngishonisa phezulu le graph. If I lift it up, so mangi lift the graph, so everything goes up here the graph. So the whole graph will go up. Now if I take it up, nje kancane ngisusa la ngibeka la. Khumbula ukuthi siyamazi u-x la. Uba u-x wethu la. Siyamazi u-x wethu ubani la? Simthoyile u-x wethu. Yes, I think simthoyile u-x wethu. There was a question that was looking for that. Let's look at it. Yes, yes. Siyamazi u-x wethu u-1. Siyamazi u-y la. Let's look at y. In other words, where there's x, we push in 1. Sifaka 1 la. So it's 1 cubed, which will be 1, times minus 2, it will be minus 2. 1 squared, which will be 1. This is minus 3 as well. Then 12 times 1. That should give us this one and this one 7, and that one 27. So this will be 27. So the value of y there is 27. Now, if we take this thing, I guess if mangabe sikhuphula adjust nyakaza su-y, uma ngabe ngikhuphula ngishonisa phezulu, kusho ukuthi le graph yami izohamba phezulu, ngeke sathinta la, ngoba everything goes up. Once we have that scenario, izobe sithinta ngala kuphela because this line is continuous. Uma ngabe ngishonisa phezulu, izoba nama roots amangaki. It will only have 1 root, ngoba le izobe sintanta emoyeni. Do we understand that? Now, I can't take it up for me to have how many roots? 3 distinct roots. So how can we move this graph such that in our roots are 3? Okay, we're looking for the value of that movement, with that k. If ngikhuphula kanje le graph izoba ne-root eyodwa. If i-question ibithi, determine the value of values of k for which that graph equals to k has one root. Bese ngayiphakamisa nje above u-27 kancane. Okay. Bese ngiphakamisa nange-unit eyodwa. Anything above 0 bengalunga leyo root eyodwa. But la khulunywa ngama-roots amathathu. Okusho ukuthi ukuze le graph ibe nama-roots amathathu angafani, faka ngishaya kancane lapha phezulu, ngishaya nje ukuthi yahle. Let's do that. Let's see that ukuthi kuzoba khona into enjani if we do that. Kungaba khona if siyehlisa kancane so ingahamba la. Kuba igraph enjeyana. Inama-roots amangaki manje le graph? Awu 3. 1, 2, 3. Awasafani kodwa sekuthe uyehlisa kancane. Do we understand that? But kuyingozi uvele uyehlisa lokho kanjani. Ngoba suppose ukuthi le graph ngehlisa idlule 27. Kama ngehlisa ngo-28. Uma ngehlisa ngo-28 kusho ukuthi izobe ihamba la ku-1 manje. Uyabona ukuthi uma ngabe ngehlise more than 27 izogcina isine-root eyodwa. So ukuyehlisa kwami is important. So fanele ngehlise in such a way that ingafiki futhi la. Ngoba yafika la izobe isinama-roots amangaki futhi awu-2 afanayo neyodwa engafani. So they are no longer 3 distinct roots. So fanele ngehlise such a way that igcine just before this one. So ngehla up to here. 1, 2, 3 roots. So ukuyehlisa kwami fanele ku. In other words, how do I write the solution? I'm saying my solution must be greater than 0, but less than 27. This becomes how my k will be for this graph to have 3 distinct. Ukuyehlisa kwami fanele ube ngaphezulu ka-0 kodwa kube less than 27 for me to have 3 distinct roots in this particular graph. Thank you.